Section 10.2.4, how many solutions, determining the number of solutions. It's our final week of class. Let's do this, guys. All right, quite the introduction we had for me right there. Yes, and you can tell I'm excited for this. I'm excited for this always. Why did I go into this line of business if I can't harness my excitement and share that with you guys here? So far in this course, you've seen many types of equations, some with no solutions, some with one solution, and yes, others with two solutions, and still yet others with an infinitely many number of solutions. Is there a way to predict how many solutions an equation will have without solving it? Today you will focus on this question as you study quadratic equations. Those good equations that you now know how to solve because you've taken Algebra 1. That's right, you've taken. We're kind of putting that in the past tense because you've kind of done everything you need to do in order to do this class, and then this last week is just kind of gravy on top of things here. So anyways, 1060, number of solutions. This is just the most to get you to think about a little bit more thoughtfully about how you solve quadratic equations and what's possible for getting an answer. So you always want to be predicting what your answer is going to be as you start solving a problem. That's going to make you a better math student and a better worker in general. So anyways, number of solutions. From problems in prior chapters, you know that some quadratic equations have no solutions. Some have only one solution, some have two solutions. Hey guys, you're telling me the same thing I just read a second ago. How can you quickly determine how many solutions a quadratic has? Okay, so that is really the key question of this problem and kind of this lesson, is that there are methods here that you're going to want to know with how can you quickly determine number of solutions of a quadratic. So in this particular problem, it says here, next sentence, the quadratic equations written below are in perfect square form. Yes, 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 yes. See math notes at the end of this lesson. Oh, do I go all the way to the end? Oh, there's no math notes there, but I'll add the math notes on and maybe that will tell you something about perfect square form. Perfect square form was this. I don't know if you remember this at all. This is just kind of mentioned very quickly in the book earlier, but perfect square form is ax plus b, close parentheses, squared equal to c, equal to a constant, right? A number on the right side, no variables. You just see a number right here. So we got one variable, right? We got a coefficient in front of that variable. So it's kind of like a little factored form action here, but it'll be having a perfect square, right? Instead of ax plus b times ax plus c equals a constant. There's a way to write that with for quadratic equations. So when it's written like that, we're going to see how many solutions they're going to have. How can you quickly determine how many solutions is what this problem is all about. So with your team, solve the questions below and note how many solutions there are. Express your answers in both exact form and approximate decimal form. Look for patterns among those with no solution and those with only one solution. Okay, so we're looking for maybe sums with no solution, with one solution, and yes, 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 yes. I think two solutions is probably going to be the other one because we're used to getting answers where there are two solutions. Be ready to report your patterns to the class. Okay, so maybe we'll get some notes going up here so you can kind of put this in as number of solutions of quadratic in perfect square form, which is this, ax plus b squared equal to c. And we're going to have three situations, it looks like. One where you get no solutions. It's sort of guiding us this down here. So we have no solutions here, no solution. So I put this in your notes. And we'll fill in the details here as we work. When we get no solutions, situations where we get one solution, and situations where we get two solutions. And I've started out A and B together because I'm hoping you're kind of gazing ahead here, kind of pacing what you're going to have to think about, A and B, because these are actually going to have different numbers of solutions. Let's start with A first. Let's do this one first here, okay? So here, you're looking at your paper. It should say the quantity x plus 4 squared up. And once you square that x plus 4, you get positive 20. Okay, get positive 20. Okay, so remind me here, right? Remind me, x plus 4 squared. Are we going to get one or two solutions in this one? Well, if we take x plus 4 here, 4 and we square it on up, we get positive 20. That means we need a number that, when multiplied to itself, becomes 20. And what number is that? Well, it's not 4, that would be 16, right? It's not 5, that would be 25, but also it's not negative 4, because that negative 4 squared would also be positive 16. Negative 5 squared would be positive 25. So x plus 4 should equal somewhere between 4 and 5. And this is why they're asking us to write in the answer in the exact form and the approximate decimal form. So let's do that now. We're going to get two answers out of this. And think about maybe what's underneath the square root symbol in terms of why you know that there are going to be two answers here. So square root of 20 is a real number. So, right? So on all these problems here, you're just taking the square roots of both sides and analyzing and thinking critically about this. So x plus 4 would equal plus or minus root 20. At this step here, guys, I would do my simplification step for simplifying radicals like you did a few Thursdays ago, because square root of 20 can be simplified. And reminder on that, I know you did the classwork. I got some questions for it afterwards. It's a little bit harder. So let's simplify the square root of 20 over here. So remember, we can rewrite radicands. That's the expression that's underneath the radical symbol, the square root symbol. We can rewrite it in terms of its factors. And the factor we're looking for are the perfect squares here. So you're going to have to maybe do this in some of the other problems here. That's why I'm going over it. But the perfect squares are 1, 4, 9, 16. What else? What do they have in common, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And so on and so forth. 6 squared is 36, 7 squared is 7 times 7 is 49, and so on and so forth. So if we can get one of these perfect squares to go in to be a factor of 20, then we can factor out a value out of that square and simplify the value. And so the perfect square here that goes into 20 is 4. And how many times is 4 going to 20? That's right, 5 times. And then we can, in order to simplify this expression here, right, we're trying to simplify square root of 20. We can take the square root of 4, which is what? What's the square root of 4? The principal square root of 4 is positive 2. So we get 2 root 5. So I'm going to rewrite that down here as x plus 4 is equal to plus or minus 2 root 5. And maybe you did that too. Hopefully you're practicing that skill, but it's not going to be very important to geometry. All right, next step. So we got x plus 4 has got to represent either positive or negative 2 root 5. So we just got to take away that 4 to isolate x here. Subtract 4 from both sides. So 2 root 5, that's an irrational number. You can't add that to a rational number, which is the number 4, right? Number 4 is an integer, right? It's a whole number. It is a rational number, right? It can be written in terms of division, right? 4 over 1, or in terms of a fraction. So it's a whole bunch of different things, but the key thing is that it's a rational number, and you can't combine rational numbers to irrational numbers. So we leave this as the quantity 2 times by 5, or the product 2 times by 5, plus or minus negative 4, or the other way around. Sorry, negative 4 plus or minus 2 root 5. And that's going to be my answer. So here's my answer. We work on solving them, and it says, note how many solutions there are. There are 2 solutions to this one. And maybe we have a guess as to why, but let's keep doing problems before we fill in our notes in red here on the upper right side. 2 solutions. So this one would go with number 3 right here. So why would there 2 solutions there? Think about that. Next one here, I have these square root symbols in at the beginning when you opened up this assignment. So maybe you looked at it and you thought something was kind of weird about this one. Yes. Well, if you think about this, 7x minus 5, if you square it up, right? If we square it up, well, think about what the original statement was saying. If you had an expression, 7x minus 5, and it ended up getting squared, right? You multiplied it to itself, and then it would have to equal negative 2. What's wrong with that? Where is there a contradiction with that in terms of how you know numbers work and how you know math work? Because there's a problem there. 7x minus 5, that's an expression. It represents a certain number, right? And when you square that certain number, it equals negative 2. Is that possible? Well, can you have any number? Is there any real number, right, where you multiply it to itself and it becomes negative 2, or it becomes any negative number when you multiply it to itself? No, any real number when multiplied to itself is a positive number. So if you have a negative number and you square it, it becomes a positive, because 2 negatives multiplied to one another is a positive number. So in this situation, this is not good, right here. This broke math right here. Here we know that this is not a real number. The square root of 2 of negative 2 is not a real number. This is something else. This is something you'll study next class called an imaginary number, because when you get to quadratics, you typically end up solving for a lot of negative square roots. It's weird, right? You end up with equations, and they're negative, and then you end up taking the square root of them. And a lot of times you would say this, right? No real solutions. So guess what, right? Once you take enough math, or once the mathematicians from thousands of years ago were solving problems like these and developing math, they decided Why do we just keep writing no real solutions when we have a negative square root like this? Because -2 is here. But what if it said -20 here on the right side? What if it said negative 200? What if it said -500? Why would we just keep saying no real solutions? Shouldn't we be saying something different? And that is the idea of something called imaginary numbers, which we'll get into next lesson. So anyways, no real solutions there. All right, step three. Step three, let's do this one. Okay, cool, perfect square form. I think we know how to solve the quadratic perfect square form. Just take the square root, right? Remember, a square root cancels out the squaring of a side, okay? And then we're left with 2x minus 3 and equal to, oops, what did I forget? Yes. 2x minus 3, square it. Becomes positive, so that means 2x minus 3 could be negative square root of 49 or the positive principal square root of 49. So plus or minus 7 is what we have here on the right sides. How many solutions are we going to get? Why are we going to have that many solutions? Oh, let's figure it out. So what we need to do is we need to add 3 to both sides. And we get 2x equaling positive 7 plus 3 is 10. And positive 7 or negative 7 plus 3 is negative 4. Divide both sides by 2. And we get x equals 5 or negative 2. How many solutions is that? What did we just solve for? Are you paying attention? Yeah, you were. There are 2 solutions. 2 real solutions to problem C so far. Are we ready to put in some notes? Are we ready to write some stuff down here? I don't know. Maybe we should wait and observe more. But I think we know why there were 2 solutions there. Let's try this one. Okie doke. Perfect square on the left side. We need to we need to isolate the variable that's on the left side. So let's take the square root, right? Square root property. The square of something, take the square root, and you got to put plus or minus on the other side if you're taking the square root of this, and there's a variable there introducing the square root. So we're going to have 5 minus 10x, because we eliminated the squaring by doing the opposite, which is taking the square root, gets rid of that, and then we have plus or minus 0 on the right side. Ooh, when we see plus or minus 0 on the right side, what does that mean? Is it possible? Is it possible to have plus or minus 0? How many numbers is that actually? Well, does 0 have a sign, right? Or is 0 just kind of hanging out in the middle of the number line? Remember, positive, go back to your roots here. You're like your background in math, right? Your positive numbers are here on the number line, negative numbers are here, so what's the deal with 0? That's right, 0 is a neutral number. It's completely by itself right there. It's neither positive nor negative. So I think you know where this is going. How many solutions are there going to be to this one? Well, can you have, is positive 0 any different than negative 0? No, it's not. So we're just going to put 0 here. And we're going to solve this equation, okay? I would add 10x to both sides so we don't have to deal with negatives. And then 5 would equal 10x. And what do we do to both sides to isolate x? We're going to divide both sides by 10. So we get 5 over 10 on the left, and we are left with x on the right side, and we get x equaling to 1/2. How many solutions? My friends, 1 solution. Why was there 1 solution? Look at that real quick, and then maybe let's put in the notes and then test it on our last 2 equations. There's 1 solution, singular. Okay, so maybe let's come up with notes and then we can do the last 2 together here, okay? So have you guys figured it out yet? Have you figured out when you're in perfect square form here, right? When you have a quadratic on the left side, and it's only a quadratic, right? So it's just something being squared and it's equal to a number on the right side. You're going to have no solutions in what situations? Oh, yes, here, B, we saw in B. Just B so far, just B, that's it. When we see a negative number on the right side, so I'm going to put here when C is negative. Maybe you say when the other side of equation is negative. But if it's perfect square form, right, we have an expression on the left side. It's being squared, and it's equal to a constant on the right side. So if that constant were a negative, you're going to have no real solutions because there's no way you can square the left side with using real numbers, and the result of which would be on the equivalent to a negative number. That's just impossible, right? You're always going to have a positive number if you square real numbers, okay? C is negative, no solutions. What situation do we have 1 solution? Where do we see that? 1 solution, 1 solution. Well, the only way we can square a number where we get only 1 solution to it is if that number is 0, right? So 0 squared is 0. And 0 is the only thing that can get us to 0 when squared, right? There's not a positive or negative value that could get us to 0. It's just 0. So when C is 0, you're going to have 1 solution. So one thing you quickly check in the equation, double check yourself before you wreck yourself. You're all just learning about what things to expect to avoid mistakes and sort of understand there are these little things to look after. And finally, two solutions. When are you going to have two solutions? Ah, yes, when C is positive. Let's see if these notes can help us out on this one. All right, check this out here. Is this in perfect square form? Sure as heck is. This one's not in perfect square form yet. Actually, we're going to have to deal with adjusting that before it's in perfect square form here. So in this one here, how many solutions are there going to be? Oh, you can tell right away. Yes, you can, because you have notes now. There are no solutions to this one. Why? Why are there no solutions? Well, it's a perfect square. What can a perfect square not equal using real numbers? Cannot equal a negative number. Can't equal a negative number because there is no square root of negative 10. Impossible based on the logic that we have so far. No solutions in this one because C is negative. Question F. Question F is not in perfect square form. Did it say it was in perfect square form? Oh, it did earlier. It said the quadratic equation below written in perfect square form, but no. This is not in perfect square form because it's not an ax plus b squared immediately equal to a constant because we have this other constant being added to the left side. So we need to subtract 5 from both sides. And we're going to get x plus 11 squared equal to 0. And using our notes, if C is 0, we're going to have one solution for this. And the answer here, can you tell what the answer is just in your head? What's the only value we can pop in for x there? That's going to make the left side equal to 0. Ah, that's right. Negative 11 is going to be our solution here. So we take the square root of both sides. You can do it by looking inside, right? The square root symbol, the squaring, what needs to be in the parentheses here needs to equal 0. Because 0 squared is the only way we can get to 0 on the right side. So that means we got to put in negative 11 for x, because negative 11 plus 11, that equals 0. It's kind of like the zero product property, basically, is what you're using to solve this one here. So in this problem here, x equals 11 is your solution. You could take a square root of both sides, even drop a plus or minus in front of it, but plus or minus 0 is just going to be 0. Subtract 11 from both sides, you get x equal negative 11 for your answer here. Got some company with this car in the background here. So anyways, helping us wrap up some quadratic solving problems. Let's keep moving on. 1061, use the patterns you found in 1060 to quickly determine how many solutions there are for each quadratic below. You do not need to solve the equations. Cool. Well, hey, change it to perfect square form. And I'm going to know immediately how many solutions are there going to be here. Look at your notes. Look what we just took notes on. A perfect square equaling to negative 6. Can you square something and it become negative 6? Heck no. Heck no. This one is no solutions. Think about how quickly you can solve these problems now. Normally, I give a few minutes on this in class, and then what's nice is like, hey, you can just answer it right away right now. No solutions. How many solutions here? One solution for this one. And finally, there are going to be two solutions for C. Why? Why, though? Make sure you understand why. Okay, one solution. Because square root of 0, the plus or minus square root of 0 is only going to have one answer, which is going to be 0 for it. So one solution here you'll eventually get for n. Here, you'd have a plus or minus 11. So this would be an irrational answer here. You don't need to solve them. Don't need to solve the equations. So we're not doing this. This is just quickly telling how many solutions there are going to be. So it all depends upon where the square root ends up going. This is how we can tell. Here, there are two solutions because our constant is positive. Here there is one solution because our constant is 0, and here there are no solutions because our constant is a negative number and can't take a square root of a negative number. 1062, how can you tell how many solutions an equation in standard form, ax squared plus bx plus c equals 0 has? Explore that question by completing this investigation. Solve the quadratic equation. Write both the solution in both exact form and approximate decimal form. Quadratic equation. Messy, messy, messy. So let's check this out here. Remember, kind of deciding how to solve a quadratic equation. Do you remember the three main ways? Okay, there are kind of three main ways. Think back to the video, right? That Ohio, the quad solve dance rap. That was pretty freaking sweet. It was bars. But anyways, think back to that. That sort of recommended three ways to solve a quadratic that we studied. We studied a couple other ways, like using a graphing calculator and whatnot. And this perfect square root stuff. You're not going to do the perfect square method up here, but you might do something else related to a square. Yes. The ways we had to solve a quadratic were factoring and using zero product property. That was one. Step two, then you'd move on to, can I do completing the square, right? That's an elegant way, an easy way to do it without leaving too many mistakes, because it's not that complex of a formula you need to follow. And then speaking of formulas, the third way to do it was the quadratic formula. So we got to decide which way we're going to do to solve this guy right here. So this is kind of a review of, hey, how do I solve a quadratic like this? Go through my checklist and solve this. Well, looking at this right here, it's definitely not factorable yet, because we know we have a constant that's a fraction, right? When we have fractions, let's not use factoring, because whole goal is to avoid fractions with factoring. We want to have integer factors. But one thing I might do before solving this is to make it an easier equation. So what I might do is, because we have a half here, if I have a half of a term, or like a half of a variable or a half of a constant, just being a half there, I can double both sides, multiply both sides by 2. And because 0 is on the right side, that's easy. Right, if I'm making the right side 2 times bigger and making the left side 2 times bigger, I mean, both the right and left side represent 0. So it's still going to equal 0 here, but we're going to know that the expression here equals 0 because it's just twice as much as 0. So 4x squared minus 6x plus 1. Does everybody understand why I did that? Equal to 0. Just because I want to deal with whole numbers here, right? Whole numbers, because that's a lot easier. I can tell if I can factor a lot more easily, and I can also use the quadratic formula a lot more easily. I know I'm not going to use completing the square because my front term is 4 and my last term is 1, so I'd have to divide everything by 4, and that wouldn't be good. I'd end up with a fraction at the end. So let's not do completing the square. Only really do completing the square for now if your lead coefficient is 1, meaning your x squared term has an a of 1. It's an a of 4 right now, so we're not doing completing the square. So let's look at this. Is this factorable here? 4x squared minus 6x plus 1. Is that factorable? Well, we got to think. 4 times 1. What's 4 times 1? It's 4, of course. Okay, so can we get two numbers that multiply to 4 and add to negative 6? No, we can't. Its factors are just 4 and 1, right? 4 and 1 are negative 4 and negative 1. And that would get you to a 5 or negative 5. Not going to get you negative 6. And then 2 and 2, those are the other ones, right? That would get you to negative 4 if it's negative 2 times negative 2, or we add those two together, get negative 4, or positive 2 also would add together to become 4. So not going to get us negative 6, so we got to use the quad formula for this one. That's the method to solve this one. Have to use it. You understand why? It's not factorable, and we don't know how to complete the square for non-a's of 1. Use quadratic formula. So let's do that. Yes. We're in the form ax squared plus bx plus c equals 0. So that means x equals negative b, so negative 6, plus or minus the square root of b squared, negative 6 squared, minus 4ac, all over 2a. All right, let's get this solution here. So let's start simplifying it down. I'll go to the right here. Negative 6 is positive 6, plus or minus the square root. What part of this is going to tell us how many solutions we have? That's right, the square root part here. Thinking ahead a little bit. Negative 6 squared is 36, minus 4ac. So again, one thing that I do to tell is with a sign that I have here is I'm going to circle my negative symbol right here. Do I have any other negatives to circle? Okay, so what's this going to tell us when I multiply this? Negative 4 times 1. What's that going to tell us? If I have one negative here, if I'm multiplying numbers and one of which is negative, what's my product going to be? It's going to be negative, okay? So I always do that because then I can just focus on what's 4 times 1. And what we got to do, let's do 4 times 4 first. That's 16. And we have that 1 factor to multiply to. That would be 16 times 1. So that would be 16. And then I knew it's already negative because I only had one negative symbol there. So I got minus 16. This is all over 2a, which is 2 times 4 is 8. And yes, we're going to have to simplify that square root symbol. So I'm going to update this here. This is 36 minus 16. I'm going to cross that out. Underneath the radicand, we have 20 again. So we know that that's going to be equal to 2 root 5. So I'll do that down below. Because remember, over here we did that out, right? Simplifying radicals. This is one we had to simplify. Square root of 20 equals square root of 4 times 5, right? 20 is 4 times 5. Square root of 4 is 2. So pull it out. Can't take the square root of 5. That's as simplified as we can make that irrational number there. So x is going to equal, right? So x equals this, right? We got to get our answer in a simplified form, because we want to present it as simply and elegantly as possible to our readers, which is probably your teacher, probably good old Mr. Fortin there. And so this is going to be 2 radical 5. We replaced square root of 20 with 2 radical 5. And this is all over 8. So remember, when you have this, should we break up into 2 equations? Let's simplify it first a little bit before we break up into 2 different equations. So here we have 6 over 8. So I bring it apart here, right? This is just a sum here. 6 plus 2 root 5, 6 minus 2 root 5, all over a common denominator. So when you're adding in a numerator and you have a common denominator, you can break your fractions up. That's totally legal. And I'm not going to spend the time really going over that a ton, but you got to trust yourself, right? Some of those math rules you've learned in the past, got to start trusting yourself with it. If you have right, a sum or a difference in the numerator and you have the same denominator, then you can break your fractions up. And I'm just doing that so we can see the simplification of fractions a little bit easier. You don't have to do this step. So anyways, we get 6 over 8 here. What's the most simplified you can write 6 over 8? Well, both are divisible by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So 3/4. And then I get plus or minus. Yeah, there's no reason to break this up because plus or minus is still going to remain in our answer. Plus or minus, I get, again, 2. 2 is divisible by 2. So I can divide the top by 2. So if I do 2 root 5s, then I'll have 1 root 5 left after I divide by 2. Divided the denominator by 2, and then I have 4 left after I divide 8 by 2. And then I'm going to get root 5 over 4. And hey, there was really no reason for me to break up that fraction like this other than maybe to see the simplification a little bit here, because now I'm just going to combine it back into a simple fraction here. So because we have a common denominator here, look, and we're just adding here, we can just, and subtracting technically, we can just put that plus or minus back on top of the fraction and show that our denominator is common. We have a 4 denominator there, so we can write it as one kind of expression here with one kind of fractional expression, and we're good to go. Okay, so that is the exact form. It's asking us for the approximate form. Oh, that's fun. Wow, it's making us do lots of work here. Should Mr. Fortin turn on his camera so you can see his graphing calculator? No, I'm not going to do that. I'm just going to use my computer graphing calculator. So we got here, maybe I need to escape out of this so I can see everything at the same time. There we go. So first thing I'm going to do is maybe do the square root of 5. It's about 2.23. That makes sense, right? Square root of 4 would be 2, so it's a little bit above 2. And then I'm going to add 3 to it. So I'm going to get the positive 1 first and divide by 4. And I get 1.3 or so. Okay, so x is about 1.3. And I'm going to get a negative 1 out of that. Yes, it should be negative, because if I do the square root of 5, make it negative, and then I add 3 to it. Oh, this is going to be positive too. Positive as well. Yeah, negative 2.23 plus 3 would get you to a positive number. Divide by 4, you get a 0.2 or so. So about 0, I'm going to go 0.19. Okay, so this is my approximate decimal form. All right, so anywho, that's me solving it, writing solution and solve both the exact form and approximate decimal form. All right, so anyways, part B is actually, maybe we already did this in part B. I'm trying to look at what it says here. Change the 1/2 of the end of the equation to another number so you have an equation with no real solutions. Oh, no, we haven't done this yet. Okay, so it's saying, it just wants us to think, what if we had been given an equation like this that had no real solutions? Well, if the C was 1/2, we ended up with 2 solutions. What's something that would end up with no solutions here? What would the 1/2 to be so there's only 1 solution? So let's check this out. What is it saying here? Man, that's kind of a tricky problem here. Have an equation with no real solutions. So let's see here. What would have to make, what would our C be, okay, for no real solutions? Well, what's the reason why this had 2 solutions? Why did this have 2 solutions? Well, inside the square root symbol is a square root of a positive number. So we have 2 real solutions. So in order to have no real solutions, inside the square root needed to have been a negative number. So maybe let's try to figure out, right? Originally, we had inside our square root symbol, we had 36. that's negative 6 squared, minus 20. And I'm going to put minus 4ac right here. So 4 times 4 is 16. And then our c right here was only a half earlier, right? Only a half earlier. So, and then we doubled it because we doubled everything. But anyways, so it's 1 when we use the quadratic formula. What would we need to put in there in order to have no real solutions? Okay, so it was only 1, and that kept the 36 from not going below 0 once we subtracted 4ac from it, because we only had to subtract 16. So if c is a really big number, right, because we only had 1 negative right here, if c is pretty big, we're probably not going to have any solution. So I don't know, maybe we'll put 100 in there. Okay, so maybe we had 100 right there. So originally, remember, we doubled it, so maybe no real solutions is this, 2x squared minus 3x plus 50, right? A really big c, and if it's positive, right, a really big positive c, and you have a positive a right there, probably not going to have any solutions to it, because your square root symbol would end up being negative, okay? End up being negative. So square root, we'd end up with a square root of a negative number, and this would be no real solutions. What would the 1/2 be so that there's only one solution? Oh, interesting, interesting, interesting. So this would have to, well, we'll see 2 real solutions when the square root's positive, no real solutions when the square root's negative. Well, what about if we get 0 here? So if we had 36 minus 4, a ended up being 4 when we doubled everything, what would c have to be? So I'm going to put 2c here, because remember, we doubled everything before we used the quadratic formula, because we had the half there we dealt with earlier. I don't want to redo the work. So we would have to solve this equation right here. 36 minus 4 times by 4 times by 2c equal to 0, because if this whole thing, right, equals 0, if this whole thing equals 0, right, we have a square root of 0, we would have one real solution. And this is the thing that really, this is a keep an eye on in your assignment, right? Just going to allow you to solve problems faster, because you'll know whether or not you actually have to do them, because you might get to no solutions first, or 1 solution, 2 solutions. Just know what to expect. So here, C, let's get C here. Did you get C? This was kind of tricky. It'd be impressive if you guys got this on your own here. Okay, negative 4 times 4 is negative 16, times 2 is negative 32. So 36 minus 32c equal to 0. Add to both sides. We're going to add the 32c, so we get 36 equaling to 32c. Divide both sides by 32. And I get, well, 4 goes into both those. 4 goes into 32 8 times, and 4 goes into 36 9 times. So this is going to be 9 over 8. So if C were 9 over 8, then there would be only one solution. Tricky problem. Usually only a few people get that one right on their own. We do that in class here. So no real solutions, a big number. So 9 over 8 is sort of that limit there. If it's greater than 9 over 8, you're going to have no solutions. If it's less than 9 over 8, you're going to have 2 solutions, because your b squared minus 4ac is going to be positive, like it was in part A. Explain how you can tell from the standard form whether the equation will have 0, 1, or 2 real solutions. Well, it says the standard form all here. They all work in tandem together. So this is how you can tell. Square root of b squared minus 4ac, okay, if it is positive, you'll have 2 real solutions. And we don't even need that square root symbol in front, because the idea is that if what's underneath the square root is positive, then your square root will also be positive. If what's underneath the square root, which is b squared minus 4ac, if it were negative, a negative number, you'll have 0 real solutions. All right, these are notes. These are notes. These are really important you get this. This is like a main thing. This is something called the discriminant, which we'll read about at the end. 0 real solutions. And finally, the last one, b squared minus 4ac, if it is equal to 0, then we'll have 1 real solution. Because then it'll just be negative b over 2a would be your solution to the quadratic formula. 1 real solution. And these are important notes So either note down or just make sure you get to look after, because this is something called the discriminant, which I'll go after. B squared minus 4ac is the discriminant. It tells you very quickly how many solutions you're going to have to a problem. So I'm putting down here, and then we'll circle back to it at the end. Important notes. All right, 1063. How much more time do we have here? Oh, man, they give you lots of problems, guys. We're going to be on this for a while. How many solutions do the equations below have? How can you express the solutions? Well, hey, this just looks like a parabola. This is sort of a trick question here. So this is a parabola, so I'm going to put infinitely many solutions. Notice here, 9x squared plus 4x minus 6 is not equal to a particular number. It's equal to another variable. So if we have this here, it'd be a quadratic graph, infinitely many solutions. And how can we express the solutions? We could graph it. And how can you express the solutions? Graph the parabola. So this is just a silly question that's supposed to get you thinking about the difference between an equation, a normal equation where you just have x equaling to something and x stuff's happening to x, and then a function which is x and y working together to find common sets of solutions, coordinate pairs, ordered pairs. Graph the parabola is a way we can express the solutions. Okay, anyways, I'm moving on here because maybe it's going to help you practice this. Use the graph and table on your graphing calculator. Check out your solution to part A on problem 1062. Okie dokie, when it says using graphing calculator, we're using Desmos, my friends. Let's use Desmos. Start graphing. And let's check your solution to part A. So just part A. All right, so I'm going to do 9x squared plus 4x minus 6 equal to y. And these are all my solutions, right? When negative 1.395 is x, then y is about 5.934. And we got some roots. Irrational roots, it looks like. Do we have a vertex that's irrational? Or this is a rational vertex for sure, irrational vertex. And then, yeah, but kind of a whole bunch of funky solutions to this this parabola. Again, parabola is pretty much anywhere on the xy plane. Notice here how thin this parabola is. That's because of the 9 here. We didn't spend too much time on this first semester, but the 9 here in front. This is called the stretch factor, right? Stretch factor. So the skinnier the graph is, the higher the value of A is going to be in your equation because it makes it grow and decay very quickly. Whereas if you had a fraction like a half or something, look how fat that is by comparison, or a fourth, super fat parabola. Okay, but a lot more thin if your A were a big old number like it is right here. Okie doke. That's that. Okay, so we confirmed using graphing calculator. There was infinitely many solutions, and that's just all the points on the graph. Okay, so a reminder, that's just when y is what your equation's equal to, not a particular number. You're gonna have all sorts of solutions. Okie dokie. Consider the equation here. Absolute value of 2x minus 5 equals 9. Perfect. Yes. Let's do an absolute value problem here. With your team, solve absolute value of 2x minus 5 equal to 9. Record your work as carefully as you go. Check your solutions. Well, here, let's look inside. 2x minus 5, it's got to equal. This is sort of the definition of absolute value, is that that's plus or 9 units away from 0. And then we got to solve. We got 2 equations, got to solve it. I'm going to break it apart. Absolute value, don't ask me why, but I like to just break them apart like this. Do the negative 9 over here, but 2x minus 5 in this expression here, because the absolute value is positive, could also equal a positive number, a positive 9. And then let's solve both. Add 5 to both sides, we get 2x equaling to negative 4. Add 5 to both sides, we get 2x equaling to 14. X equals 7. And x equals, wait, did I do something wrong here? What did I do wrong? You had to subtract 5 here. This is totally wrong. You shouldn't never really get, unless your absolute value is just absolute value of x equal to something, but if you have other operations here, you shouldn't get the same numbers, the opposites of each number here. You should get different amounts. So I need to add 5 to both sides. So this shouldn't have been minus 14. So this one I was doing correctly. 14 divided by 2 is 7. This one I was doing incorrectly. Because I need to add 5 here, I should have had negative 4 here. Negative 9 plus 5, right? That's how we get rid of that 5. Because we'd add 5. That's the opposite of subtraction. So that goes away. Negative 9 plus 5 is negative 4. So we get 2x equal to negative 4, and then divide by 2. and we get -2. So I got -2 or 7 as my solutions for X, part A. Part B, can absolute value have no solution? With your team, create an absolute value that has no solution. Oh, yes, 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 yes. We've seen something like this before. How can we be sure that there's no solution? Well, let's stick with this original absolute value. What would it have to be equal to get no solution? Think back to this lesson. Where were we seeing no solutions? Oh, that's right, here. There were 2 solutions here because this was 9, and there are 2 values of a number that are 9 units away from 0, +9 or -9. So, are there any numbers that are a negative value away from 0? So say is there a number that's -5 away from 0? No, -5 is 5 away from 0, +5 away from 0. So this would have no solutions. So this is the same thing, right? Just trying to show you it's the same thing as kind of the discriminant in the last problem. And the perfect square form, if you have to take a square root and it's negative, then you get no solutions. If you have to take an absolute value that's equal to a negative number, that's impossible, right? Because absolute values are all positives. There's no solutions there. Likely, create an equation with an absolute value that will have only one solution. Justify will have only one solution. So let's do that. Let's do the same action here. 2x minus 5, it'll have one solution because there is one number that is 0 units away from 0. And that would be 0 here. So x would have to equal 5 over 2 in this solution here. Okay, so that's sort of my justification. There'll be one solution because only 0 is 0 units from 0. 1066, learning log. How can you tell without solving how many solutions a quadratic equation has? Be sure to consider all 3 forms of a quadratic equation in the math notes box below. Respond in a learning log entry. Be sure to include examples for each. Title this entry, number of solution, and include today's date. Okay? 3 forms of a quadratic equation. Oh man, it's going to be a lot here. Well, quadratic equation, how many solutions? Ultimately comes down to the square root. When you take the square root, if it's positive, 2 solutions. If it's got to take a square root of a negative number, it's no solutions. Square root of 0, you're going to have 1 solution. And the thing you use to test that in standard form is this thing called the discriminant, which is the part of the quadratic formula b squared minus 4ac, because that's where your square roots come into play. Right? So if b squared minus 4ac is positive, 2 solutions. B squared minus 4ac is negative, it's no solutions. B squared minus 4ac is equal to 0. There's 1 solution there. And let's check out the math notes from this section. And here it is. There are 3 main forms of a quadratic function: standard form, factored form, and graphing form. Similarly, there are 3 forms of single variable quadratic equation. Standard form, any quadratic equation written in this form, right? This is the standard form. It's just ax squared plus bx plus c equal to 0. Then the factored form, any quadratic form written in this, right? A times x plus b times x plus c equals 0. Perfect square form, any quadratic function written in the form yada, 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 right? Parentheses. X minus b squared. Oh, they put minus b. I put plus b earlier. Sorry about that. So perfect square action there. Anyways, solutions to a quadratic equation be written in exact form. Okay, so yeah, here, kind of what we did earlier, right? We can't take the square root of stuff, or approximate form. Okay, so these math notes actually really aren't super useful. I was expecting them to talk about the discriminant in this one here, but they don't. But anyways, really the ones where you can see how many solutions there are very quickly are, of course, the standard form, because there you can grab b squared minus 4 times ac and decide very quickly how many solutions there are going to be in perfect square form. You just look to c, and if c is positive, 2 solutions, negative, no solutions, 0, 1 solution. Just like the discriminant where b squared minus 4 is that's it, guys. This was a bit faster of a lesson. Believe it or not, it was a long video, but hopefully this lesson flowed okay for you guys, because coming on up, next lesson, whew, that's a doozy. We've got a big old proof in the next lesson, and then Friday's lesson, your final lesson of the year, really isn't too bad at all. We'll just be kind of solving some problems and moving on with our lives. And we shall proceed with grace and wonder and confidence. Beauty of it all here, living on Earth. Thank you very much, guys. Take care. Goodbye.
Learn about quadratics. Let's go. Hey, yo, starting with quadratics, a difficult topic. Compared to other methods, you could say that it's exotic. So, take your x, make it equal minus b, plus or minus square root b squared minus 4ac. The next and final step, put it over to a. And if you do that right, then you know you can display the quadratic equation formula for the entire class. Just make sure to check your work. This can be a hard task. If you think you messed up, no worries, just ask. The primary goal in math is to pass. But if you can't get past that, then you can surpass any math problem, not just everyday life. You'll be zooming through your homework cause you're Albert Einstein. Wait, I think there's something I forgot to mention. Negatives under square root, a whole nother dimension. No solution, retribution, gonna need some institution of a new number or method. Maybe substitution, I don't know. I'm just here to give you guys support. And if you want the real math help, go see Mr. Fortin. Yo.